Ever wondered how civil engineers calculate the weight of materials? Or how they determine the optimal thickness for a slab? Well, today, we're diving into the world of civil engineering to explore some key information and formulas that every civil engineer should know. First, let's look at the density of common materials. Steel is approximately 7,850 kilograms per cubic meter. Cement weighs in at around 1,440 kilograms per cubic meter. Bricks can range from 1,682 to 1,920 kilograms per cubic meter, depending on the type. Sand varies from 1,100 to 1,600 kilograms per cubic meter. Now, let's go over some important points every civil engineer should remember. The minimum thickness of a slab should be 125 millimeters. The water absorption of any material should not exceed 15%. For cubes, the dimension tolerance is plus or minus 2 millimeters. When it comes to reinforcement bars, lapping is not allowed for bars with diameters more than 36 millimeters. The minimum diameter for dowels, rods, and chairs should be 12 millimeters. The longitudinal reinforcement should be no less than 0.8% and no more than 6% of the gross cross-section. Remember, the free fall of concrete should be limited to a maximum of 1.5 meters. The water absorption rate of bricks should not exceed 15%, and the pH value of the water should not be less than 6. Now, let's move to calculating cement, fine aggregate, and coarse aggregate for mortar mixes. For example, consider a 1:4 mortar mix, where 1 cubic meter of cement mortar work is to be done. The 1:4 ratio means 1 part of cement by volume. To summarize, understanding the density of materials and key points such as the thickness of a slab, water absorption rates, and reinforcement requirements are all crucial in civil engineering. These elements help to ensure the structural integrity and durability of our buildings and infrastructure. Remember, the calculations we've discussed today are essential tools in the toolkit of any civil engineer. They help to ensure that our buildings and infrastructure are not only strong and durable, but also safe and efficient. So the next time you see a skyscraper or a new highway being built, you'll have a little more insight into the calculations that go into making these structures possible. Thanks for joining us today as we explored some of the important information and formulas in civil engineering. We hope you found it informative and helpful in your understanding of this fascinating field.